Good morning. So welcome to the morning session. Hope everybody had coffee because we'll be going to a 60-minute of fully filled up slides. My name is Jignesh. I'm the product manager for RDS Postgres. Quick poll, how many of you are using Postgres right now? Very good. You are officially my favorite customers. So what we're going to do is we're going to quickly look at some of the things of how to use Postgres. I'll be focusing more on the RDS engine, Postgres engine on RDS, but I'll be also covering a few things on EC2, Postgres on EC2, and also Amazon Aurora with the Postgres compatibility out there. So quick introduction to Postgres. Postgres is an open source database which has been in active development for many years. A lot of people actually use that for different reasons, what I've found out. Some customers tell us they use Postgres because it's more compatible or closer to Oracle in terms of features. Many people actually like to do custom development on databases, so they want to kind of like extend Postgres and go for more use cases. So people have different reasons, but in the end, what you're seeing is like a growing community of users using Postgres. Some of the key features, as we all know and love of Postgres, is MVCC, which is what really helps you to kind of like make it more performant, especially for read and write workloads like OLTP. There are actually features like transactional DTL changes, which people who are more familiar with the NoSQL actually love on Postgres, because what you could actually do is like create a new column on the fly in a transaction with nullable previous values. So there are a lot of features that people like in Postgres. So what we're going to do more about is actually talk about like how to deploy Postgres, right? So there are three main ways of using Postgres. Most people in the old days would use Postgres on-premise. The new ways that most people now do is to deploy Postgres on an hosted service, or now you also have a lot of people providing managed Postgres services out there. So when you run it on an on-prem, you're basically taking ownership of everything, right? You're taking the ownership right from your hardware, your data center rooms, heating, everything that you want to do, all the way to your applications. When you actually deploy it on a hosted provider, you are essentially kind of like outsourcing your server or your hardware out, and you're starting from the operating system. So you do get a lot of benefits out there. You do not have to worry about your hardware. You still get all the elastic features of resizing your instances, growing your storage, everything out there. It does give you a lot of benefits. So especially if you're using Postgres on EC2, the benefits you get is you pick and choose what versions you want to do. You actually have full control on the operating system. You can change it the way you would like to do. You can also deploy like custom applications. Many people say, I want to kind of co-locate my Postgres with some specific application running together, or use some sort of proprietary extensions or things to kind of extend beyond Postgres. So you could do that with Postgres on EC2. But it also comes at a cost, right? Because it is a self-managed Postgres, you are basically taking the ownership of making sure that the deployment is right as per as your security requirements that you typically have to do. You have to kind of take responsibility of like the backups and restore and how they would work, the automation of that. You would also kind of like have to figure out your own ways to say, how to do my high availability setup, right? If you want to kind of say you want to set up read replicas and other features that Postgres provides to you, you have to do it on your own. That's where actually the managed Postgres service comes into place, right? Managed Postgres basically takes everything off your plate and gives you very easy way to kind of deploy and operate Postgres. And what it really allows you to do is actually helps you to put more time on your business applications or the databases that, the applications that uses the database, right? At the end of the day, for any given enterprise, meeting business needs is actually more important than actually working on the databases. This is kind of like the feedback that we typically hear. There are customers who says, what I really want is fire and forget, right? I want to deploy a database, make sure it's always highly available, and you use that, right? So this is what kind of like managed Postgres service provides you. So how do you do that on AWS? So on AWS, we have a service called Amazon Relational Database Service, which provides you essentially that fire and forget experience where you deploy an instance, you get an endpoint, you interact with it, and you start using it. Depending on your needs, you say this is for dev and test, it will give you features kind of like useful for dev and test. If you say it's a production deployment, you get more features where you could actually say, hey, I want higher availability for that, I want higher security for that. I also want to kind of like say, I want to do like automated patching, so those kind of features are available with that. RDS does not support only just Postgres engine, it also supports other open source and commercial engines out there, including Amazon Aurora, which is actually an enterprise-grade engine. Now, what is Amazon Aurora, right? So AWS, as we are very customer obsessed, customers were telling us they really want an enterprise-grade database engine that gives them the performance and availability of a commercial engine, right? So that's what we are providing with Amazon Aurora. Amazon Aurora actually comes in two editions as such. The one that was released a couple of years ago is the Amazon Aurora with MySQL compatibility, which talks the MySQL protocols. So essentially, you would use a MySQL client to connect to it. A few months back, we actually also released in a general availability for Amazon Aurora with Postgres compatibility, which means now you could do the same reliable storage engine of Amazon Aurora, where you are actually talking the Postgres protocol. So you would use your Postgres clients to do that. Moving from RDS Postgres engine to Amazon Aurora is very easy. So you could basically take a snapshot and restore out there to Amazon Aurora. So let's go deeper into kind of like overall Postgres deployments on RDS, and then wherever it makes sense, I'll be talking about Aurora or EC2 as required. So currently on RDS Postgres, we support multiple major versions out there. We kind of like have a 3-year cycle of all major versions that we support out there, and we closely follow the releases that community does and provide them in a few weeks on RDS. Our current preferred versions are 9.6 on RDS. On Aurora also, we have the major version 9.6.3 that's currently available out there. If you're using EC2, you're free to install any version that you like that is still supported by the community. We are also working on Postgres 10, so you would probably see that as soon as it's available. Now, once you have started deploying out there, one of the things to remember is like, security is typically the first concern for all enterprises, right? So in the next few slides, I'm going to cover like what do you really do about the security for your Postgres deployments. When you do a deployment with RDS Postgres, the most simplest way to deploy that is a publicly available RDS instance out there. It basically spins up a database, which is available on the internet that you can connect to it. How do you protect it? You use security groups. Now, as I said, security is a top priority, which means when we deploy an instance, what you really get is a security group with no access. So you actually have to come and add a rule for your clients that will be connecting to that instance into the security group. A common gotchas that I have seen in the setups, people actually make the security groups more wide open than needed. What you should take a little bit effort to make sure you kind of narrow it down only to the clients that have access. That would reduce your surface area of exposure on how many people can actually access the database on the internet. So this is typically good for doing like dev and test setups. If you're deploying anything for production, the way you want to deploy that is use VPC. So what VPC allows you to do is it kind of like deploys your Postgres instance in a private network as such, which is accessible by all your clients. So now you actually have two ways of controlling access, right? A, you have kind of limited who can access the database in your private network. And now you can use also security groups. Now, how would you use that? I'll give you an example. Say, for example, you have two instances. They are both in the private instance. One is using a dev setup, the other is using a production setup. You would actually set up your production setup in a way that only clients which are running production workloads are allowed to access your production setup. So it will actually have a different security group. You would do a similar thing for a dev setup, which means only the developer related applications will be connecting to that. So this is how you can actually use multiple instances, make sure you have the right protection out there. Even if there are misconfigurations anywhere else outside your control, you are protecting your instances. So that's a way you can actually use that to protect your multiple instances that you have in the same VPC. The other thing we also provide as a free feature is at-rest encryption. What essentially it does is it takes a key. The RDS systems are integrated with KMS in a way when you select a data at rest encryption, it automatically gets a key and encrypts all your volumes for your databases. Now, one thing to keep in mind is if you have already deployed an instance, it is not, you cannot really convert it to an encrypted instance as it is. So the way for you to convert an unencrypted database instance is to take a snapshot, copy that snapshot to an encrypted snapshot, and then restore it back. When you restore an encrypted snapshot, the database is the instance is always encrypted. Now, the other thing to keep in mind is once you have an encrypted database instance, all snapshots, all replicas will be encrypted. So there is no way you can mix encrypted instances with unencrypted read replicas. So when you select encryption, everything will be encrypted end to end. So kind of like, let's take a more detailed example, right? Security is almost always a key concern for databases. So a typical setup is like an application host connecting to a database instance. RDS will be taking snapshots in the background, which are like the backups. So the first level of protection that you have is your security group. This, all your clients will be connecting to your database instance. You can use SSL for your connections. By putting everything into a VPC, you have kind of reduced your exposure to only the private members within that VPC to access the database. So that's the protection you do. Using encryption at rest, you are now protected all your files that are stored on the disk. And this is sometimes actually required for your compliance reasons, so you have to do that. Now, one thing to keep in mind is Postgres client also allows you to disable SSL for your client connection, right? Which means if they actually set the variable in PSQL client with the SSL mode disabled, you will no longer be doing SSL connections to your database instances. To prevent that, RDS also gives you an additional parameter where you can say, I'm going to force SSL for all incoming connections. So the way it works is if a non-secured connection comes in, it will reject the connection. This will enforce that everybody will have to use SSL to connect to your databases. Moving on, the next thing is identity and access management for your instances. So there are two kind of levels of users that we need to know about when we talk about deploying Postgres on RDS. One is IAM, which is the identity and access management of the AWS out there. This level of users are typically used for managing your instances. So this kind of gives you very fine-grained control on who can deploy instances, who can do what user can actually modify your database settings. You can actually set policies that a particular user can deploy but not delete a production instance. You can set users that they can actually change the configuration parameters, or they can only use a parameter. So it gives you very fine level controls for your instances. If you talk about your applications connecting to your databases, then those are like the database users. So say, for example, I'm using an application, a web server, which needs to connect to a database with a user foo bar, right? So the way you would do that is you would use to connect to your database instance through pSQL using your master database credentials that you get when you deploy an instance, and once you log into Postgres, you would actually create a new user out there. Now, mind you, like the user you're creating out here is not your IAM users. These are like the database users. So this database users actually have, you can actually assign the database privileges for them to say either create like new indexes, have access to these tables and schema, and so on. So that's what I want to kind of like make sure everybody understands, like there are two levels of users. One way to kind of easily figure out like what you're using, if you're using the AWS CLI or the console, you're typically using the IAM users. If you're using the pSQL clients, then you're using the database users. That's the quick way to kind of like figure out which user sets to use. Compliance is necessary along with security, because typically that's kind of like mandated by the regulatory authorities, or you have to kind of like meet for any requirements to meet your local things, right? So on AWS, there are different compliance that we support depending on the platform you run. So some of the things I've listed out is like, depending on EC2 or RDS or Aurora, there are different compliance eligibility mechanisms that are available. It's actually a huge topic when you want to do compliance. So I would generally guide people to kind of go and start with the URL that I have on the slides. The thing to keep in mind is take like what service you are going to use that to kind of drill down and look at the eligibility requirements that you need to do to be compliant for these programs. The other thing we kept hearing from customers is like, they also want compliance at the database level, right? So I'm happy to report like we now support PG audit in the latest version of RDS Postgres. That gives you more finer grained control on doing compliance auditing of who is accessing certain tables, certain rows. So what we now support it as like you create an extension, configure it, grant that auditing user privileges to access certain tables that you want to kind of monitor for auditing. And every access that happens to that tables will now be logged into your database logs that you can actually now control out there. So this is now available on RDS Postgres. We talked about various things like how to do security, how to do auditing, how do you kind of like enforce that for all new deployments that you do on RDS, right? So the nice feature I like out there is the database parameter group. What database parameter group, as I said, is using IAM access credentials with the parameter groups, you can now create like a standard deployment parameter group for your new instances, right? So you as an admin say, all my instances should have SSL, should have PG audit, should have this parameter set, and use that as your standard template. And once you have this group set up, you can either use that same group to deploy your new instances, or you tell the person if you want any modifications, you start from this standard group, create another copy, and add more parameters that you need. That way you can make sure that your deployments are kind of like more uniform across the board. So this gives you kind of like little bit finer control, like when you're managing 50, 60 Postgres instances, this kind of helps you to simplify your deployments as such, right? When you're looking at deployments, the first thing you have to kind of like decide is like an instance type, right? An instance type gives you how much memory and how much CPU do I need for this database instance. This step is actually very hard, right? When you're deploying like a fresh greenfield application, you don't know. You would probably start small and then grow up. Ideally, one thing to keep in mind is like an instance type generally has like a trade-off. Like you are either paying too much that you're not using, or by undersizing it, you actually are trading off on performance, where you could actually just get a boost by going to a bigger size, right? So right sizing is important out there. On EC2, you do get a wide variety of instance types to select from. For RDS Postgres, our current generations are T2s, M4s, and R3s. We'll be adding more R4 types as they are available. On the Aurora with Postgres compatibility editions right now, the generation that is available is R4. So these are the choices that you have that you can use right now. On the storage side, initially, we were supporting up to 6 terabytes for RDS Postgres. I'm happy to report, as of last week, we now support up to 16 terabyte storage scaling. On EC2 also, you could use up to 16 terabyte for your volumes. The big deal about Aurora is you can go all the way till 64 terabyte. So that is kind of things. The other thing that we have improved from an earlier limit is the provision IOPS you could do for your databases. Previously, we limited that to up to 30,000 IOPS, and now, as of last week, we now allow you to go all the way up to 40,000 IOPS for your database instances. Many people still need that high IOPS to kind of sustain the write loads that they see in their production environments, right? The next thing I want to talk about is backup and restore. When you deploy a database, backup and restore is kind of like your first protection thing that you want to do. You always want an ability to make sure you can restore a database back. The way we do that on EC2 is EC2 gives you a feature to do a volume snapshot. Now, mind you, when you do your volume snapshot, you have to make sure you acquire your own database and do that appropriately if you're using multiple EBS volumes. If you're using a single EBS volume, that's fine. On RDS, RDS leverages EBS snapshots underneath it for the Postgres engine, but along with that, it also archives all your write-ahead logs. So that gives you an ability to do point-in-time restore feature also. So say, for example, somebody dropped a table at 10:42 p.m., right? If you want to kind of restore that, you can use point-in-time restore to say, I'm going to restore back to 10:41, make sure I get my database back. So that the RDS gives you a very easy-to-use point-in-time restorable feature over there. The current, the latest restorable time that we generally support right now is 5 minutes from the current time. So up to 5 minutes prior, you can deploy to that point of time as such, right? The other thing I want to talk about, there is a slight difference on how snapshots work in Aurora. In Aurora, there is always a continuous backup that happens. So it's not like something that you have to take a point-in snapshot time and restore. So there's continuous backup happening out there. So if you want to restore, you just basically go and select the time, and it will allow you to kind of restore it back to that time. One more thing that I want to highlight for RDS Postgres, if you are using multi-AZ, which is a high availability feature for RDS, when you do snapshots, it essentially happens from the secondary of that. I'll probably talk more about that in my next slide. But the idea is by doing it on secondary, you're not impacting your primary when you're still doing loads on that. So that's very helpful, like if you're having a heavy load and you still want to do a backup, by using the multi-AZ, you're kind of like offloading the backup to be happening on your secondary side of it. So I did talk about multi-AZ, but I didn't give a good introduction to it. So let me now flip over and explain how multi-AZ works. So multi-AZ is kind of giving you a high availability feature for that. So let's say a typical deployment that you have is single AZ, where you have an application talking to a database instance in the same AZ out there. You have the option to kind of turn on multi-AZ for your RDS instance. So when you do that, what it does is in the second AZ in the same region, and you can select which region you want to do this, it will now create a synchronous copy of your database on that secondary instance. And it will be writing to it synchronously. It uses physical synchronous replication. And for your application side, what you typically will do is you will use the RDS endpoint, the DNS name that you get, which will always point you to the primary of this setup that you have just shown you, right? So now what I want to talk about is, like, say something happens. Maybe the host that you were running on died, or maybe there is a crash that happened on the software side. So in such scenarios, what will happen is RDS monitoring will automatically detect that something has gone wrong with your primary instance. it would fail over to that secondary by making it the new primary. And then it will update the DNS server with the new IP address of your new primary, which when the application kind of like reloads the DNS name through the DNS server, will now get the IP address of your new primary, and now applications will start connecting back to that. And this will also work if the whole AZ dies, right? So it doesn't matter at that point of time, it will still continue to work. And once the failover completes, it will now attempt to repair the old primary and can get it back into that same steady state of highly protected multi-AZ format. So this is typically how multi-AZ work. It is basically hands-free. You set it up, and it will always do the protection and try to kind of like repair itself and come back to that steady state. Typical failover times that we have observed with multi-AZ is about 68 to 70 seconds. So which means basically you're connected, you're operating, and then if something happened, you will see like the connection drop. And within a minute or like about 68 seconds, it will be able to connect back and continue working from that. So as long as if you have applications that reconnect after some time, you probably won't see much glitch, and you can continue to work without any human needed to kind of go intervene and actually fix the problem. So it's pretty powerful that way. The next thing I want to talk about is read replicas. Postgres does support read replicas. The primary two use case for read replica is one to kind of offload load on your primary service, right? We know that Postgres is kind of like scale up into some technology, so all your writes have to go to your master. And at some point of time, if you kind of want to offload load from your master, the way you do that is you move all your read-only queries to a replica. So we support deploying such things on RDS. The other second reason that you want to use master is to kind of like do a fast recovery, right? Read replicas are fast to kind of promote also. So some people also use that for disaster recovery kind of things. So kind of let's look at how that would work on RDS. See, in RDS, I already talked about multi-AZ. So you could actually start with a multi-AZ instance, which is doing synchronous replication. In RDS, currently, whenever you deploy a read replica, it deploys read replica using the asynchronous replication of Postgres. So it essentially does a wall streaming to the other side and creates a replica. So for applications where you can separate out the read-only queries, you can actually say, now point them to the read replicas as such. Mind you, as I mentioned, because it is asynchronous, you want to kind of only redirect the read replicas that are not dependent or are okay with the eventual consistency kind of things. So these are great for like doing status updates back on your web pages and other things. If you still require like consistency read, like I'm writing something, I'm reading the same value again, I want to make sure that it's same, they all need to be redirected to the primary. So this is how you could actually set that up on RDS, and you would use your connections appropriately for that. In the same scenario, if something happens to the primary for some reason, multi-AZ will convert the secondary to the new primary. In this scenario, all your replicas will now automatically be pointing to the new primary, right? And you can use the same thing for your applications. They will connect back to the primary and continue working. If you are doing an upgrade, the way that would happen is when you issue an upgrade function with multi-AZ with multiple replicas, you will initiate the operation of, say, do a minor version upgrade. It will first upgrade all the replicas, and then it will upgrade your multi-AZ pair together, and then that's how upgrade will work, right? Another thing to keep in mind is like you still have ability to set different parameters for different replicas, right? You may want to say, I want this replica to kind of behave differently with some settings. So you can still do that. You are able to select different parameter group for your replicas. So that gives you power to kind of say, have like a variations on your replicas depending on what application connections are going to do with it. One more feature that we support, and this has been a request from customer. Like for disaster recovery, they want to put a read replica into a different region. And there are two kind of main reasons why people want to do that. One is for disaster recovery, and one is for like reducing latency. So if you have a lot of customers around the world, and you have some applications that you want to make them faster, especially for only read-only type of queries, like showing price list in the local language and stuff like that. So you could actually use the cross-region read replica feature for that. So going back to my old setup, which I started, which was with multi-AZ, with read replicas in the same region, you could do a point and click and deploy a cross-region read replica and select that out there. So if you're selecting this with your say, encryption data at rest, you are able to kind of automatically click and convert that. It will copy the snapshot out and get you an encrypted cross-region read replica at the other side too, right? In such scenarios, this will actually now give you a database instance which is faster for access for the local clients out there, cutting down your latency of your geography out there. Say, for example, now let's talk about disaster recovery, right? If you want to do that same thing, and there are two ways you want to do this, right? You are either doing this for disaster recovery, or say, example, I have my Postgres instance in US, and I want to move my whole instance to Europe, right? So this is another way you could do that same thing, like moving instances from one geography to another. So say, for example, I come back to my own setup. I want to do a move or a disaster recovery to a different region. So the way I would do that for a kind of like a minimal downtime scenario is I would create a cross-region read replica in a different region, right? I would cut applications connecting to my primary, let all the changes get flushed to your read replica on the cross-region side, promote the cross-region read replica to be your new master, and then move all your applications to that new master, and then you would spin up, you would convert that to multi-AZ to make it protected. And if you require, you can also spin up more read replicas from that newly moved master. So this is one way you can actually move an RDS instance from one region to another also. And you could use the same thing for DR testing if you want to do that way. So these are kind of like different ways you can actually achieve the use cases that you want to do for this. And you can get rid of your applications. The other thing I want to talk about is minor upgrade. So minor upgrade, the way it works in Postgres is you shut down your instances, you upgrade the binary to the latest minor version upgrade, and you kind of boot it back. You do the same thing with the one-point click in RDS. What essentially it will do is like when you issue the command out there, it will shut down your instances, upgrade them, and then restart, and you are essentially now upgraded. You have an opt-in button in RDS also. If you select automatically upgrade when a version is marked preferred, you have the option, and what we do behind the scene is based on your maintenance window, we will upgrade the RDS Postgres versions at that point, and you basically don't even have to worry about upgrading your minor instances. Major versions are slightly different. So the way we do that for major version is it is something that the user have to do on their own, but we do provide one-click major version upgrade. So I want to kind of like explain how the major version upgrade works in RDS. Say, for example, you're starting from 9.5 and you're upgrading to version 9.6. When you issue the command for major version upgrade, it first takes a snapshot. It uses PG upgrade to upgrade your database files, and then it takes another snapshot at the end of the PG upgrade and then brings the server up as major version upgrade, right? Now, mind you, like during the period when you're doing PG upgrade, you do not have a way to protect, like you do not have point-in-time recovery. So if something goes wrong during that time, the only option you have is to restore it from the snapshot that was taken just before the PG upgrade, right? So because there is a chance that it may actually fail, what we typically recommend is like before doing a major version upgrade on your instance, you take a snapshot, restore that, and run the PG major version upgrade on that test instance. And not only just test the upgrade scenario, you should also test your application because your applications may behave differently with major version changes. So only after doing that, you should actually apply that same process on your main production instance. Now, when you do the process, you will also find the time it takes to do the whole upgrade end-to-end, right? And in some cases, it just depends on the number of objects in that instance on how much time it will take to do a major version upgrade. If that time is suitable in your backup, like maintenance window, so you can use this process. If the maintenance window that you actually can allocate for such major version upgrade is smaller than what it is taking in your testing, then the other option that you have is to upgrade with AWS DMS, which is the database migration service. So I want to show how that would work. Say, for example, I'm using a 9.4.9 as one of the latest minor versions of 9.4. And in fact, I also want to do two things. I not only want to upgrade, but I want to skip a major version in between and go directly to 9.6. So if I want to do that with very minimal downtime, the way I would do that is I would deploy a new 9.6 empty instance. I would use some sort of tool to convert the schema and upload it to my new instance. You could use pgdump-s to dump the schema and load that up. If you want, DMS also provides a free tool called schema conversion tool, where you can point to your source and convert it to your destination also. So you could use that. But the whole idea is make sure you get the schema on the other side. And then you create a replication instance of DMS, and then connect source and target. So basically, for that replication instance of DMS, you say, here's my source, here's my target. And then, once you have selected that, you would select what database do you want to move. So DMS actually gives you more fine-grained control on what data you want to move. So you could select the whole instance, you could select the whole database, you could actually select only certain tables or certain schemas to be migrated, right? On the other side, once you have selected everything, on the target side, what you would typically do if you're using DMS in an upgrade scenario is either say do nothing on the source side, or on the destination side, or you say I'm just going to truncate everything if it finds anything before starting. So that way you're starting with a clean slate out there, right? And then use. The critical thing to do if you're moving this for production is to make sure you select change data capture. What change data capture does is it will keep tracking and flushing all the changes that are happening. So this allows you to continue your load on your source while you're migrating to your new Postgres version, right? Now, it will take time because the way it will work is it will move the first set of data, and using the change tracker, it will continue to move all the changes that are happening while during the move. And at some point of time, you would see okay, it has pretty much caught up with all the changes, at which point of time you would cut the access to the old database instance that you have, and then switch over to the new one. By using this, your actual downtime can be now cut down to basically under a minute, where you're essentially cutting off load, syncing it up, and starting the load on your new service. So this is actually very powerful. The only drawback is in order to use DMS, you have to use version 9.4.9 or later, because that's where logical replication is supported in RDS Postgres. And the other thing is for all the tables that needs to be migrated to the newer one, they all need to have a primary key. So if your tables do not have a primary key, make sure you either create a non-nullable unique key or a primary key, so that way it can be moved through DMS. Okay. I briefly mentioned logical replication. So RDS Postgres does support logical replication starting 9.4.9. I'm happy to say in the latest release that we did for 9.6.3, we now support two more modules, Vol2JSON and Decoder Raw. So one way to use Vol2JSON is say you are using an instance. and you want to track all the changes that are happening in the database and move it to, say, a NoSQL DB or a Kafka engine, right? So you could actually use Vault2JSON now, which will give you all the changes in JSON, and you could write your own custom handler to push those changes to a different system, which can be an RDS instance, which can be a NoSQL database, or it can be anything, right? You have the power of writing your handler and say, as my changes come in, how do I want them to be handled out? So that is now available in RDS Postgres. The way you would set it up is you would set the logical replication to 1 and make sure the user that is going to do that has RDS super user and RDS replication privileges. It's pretty powerful, like for people who are writing their own custom change tracking systems as such. The other thing I want to talk, like Postgres is very ecosystem friendly. A lot of people have developed many extensions on the core Postgres itself. When we started RDS Postgres, we started with like 32 extensions. As of the latest release that we have, we now support 57 extensions on Postgres. We are constantly adding more and more extensions. Like in the last year, we have added many highly requested extensions on RDS Postgres. If you do need more extensions that you want to get it supported, you can actually email us at the RDS Postgres extension request at amazon.com. Extensions are very powerful. The people have been using extensions for doing different things. Some of the popular extensions like PostGIS for spatial data are also available on RDS Postgres. And we also have a lot of utilities that are also designed to work as extensions out there. Also, some of the new notable features that I want to highlight compared to like last year at reInvent, we now support Linux huge pages for RDS Postgres. The huge pages actually gives you great performance boost, especially for your larger instance size, by using a larger 2 meg pages in the underlying OS system. If you have RDS connections with high number, like thousands of connections, you will see actually performance and benefits with huge pages, because what it essentially does is, like for all your memory, like connection is a process in Postgres. When you have thousands of connections, there is a lot of memory usage out there. By using huge pages, it will allow you to do better memory management and spend less CPU cycles on them. So it kind of like frees up your CPU cycles and also reduces your memory overhead. So it's out there. The other thing we actually added is start and stop feature. So say, for example, you are a dev and test. In the morning, I come in, I'm using a database. In the evening, when I go home, I don't want to use a database, right? The start-stop feature is actually very useful for that. In the evening, you can do stop of your RDS instance. It will basically essentially hibernate that instance, and you will be no longer charged for that instance at that point of time. When you come back in the morning and you start the instance again, it will start charging you for that instance at that point of time. So it's pretty useful for dev and test use cases. Mind you, like if you keep an application stopped, it will and if you don't start it for 7 days, it will automatically start it after 7 days, because for automated backups, it still needs to bring up this service. So it will automatically start after 7 days. We are also now supporting RDS Postgres in more regions. So over the last 12 months, we also support it in China and Brazil. We also started supporting encryption at rest for the smaller instances. Previously, we were only supporting encryption at rest for larger instances, but now we also support it for the T2 instance types also. Another great feature for customer is flexible RI. Say, for example, you are using M4 large, and now you have outgrown your M4 large and you want to move to M4X large. Previously, the reserved instances did not allow you to kind of move from within the family from one type to another. So now with flexible RI, if you move from M4 large and you change your database instance from M4 large to say M4X large, your M4 large reserved will still be utilized to give you discounts on your instance. So that is actually resulting in savings. So you can continue kind of leveraging your reserved instance discounts for your larger instances. It works within the same family of instance that you have. And as I previously mentioned, we now support up to 16 terabytes for your RDS database instances. I want to talk a little bit about Amazon Aurora. So one of the cool features for Aurora is better performance. So I want to kind of like spend a little bit time on like explaining how that works. In Aurora, basically, we have a new storage engine where we take the standard Postgres, and on the storage side, every time you do a wall write, it writes to 6 locations in 3 different AZs. Now, you would think like there is like, I'm going to be impacted because I'm going to write 6 AZs. The nice feature about that is it is a quorum-based system, which means it waits for 4 writes, and then it will continue with your commit, and you will move on. And the 2 writes can catch up later. The advantage of doing that is it eliminates jitters from your storage system. Out of that 6 storage system, even if 2 are slow, with the 4 fast ones that are committing, it will move on. So one of the big advantage we are seeing is like by using this system, we are cutting down the jitters due to the latencies on the storage side. So that's very powerful. Plus, writing on the 6 times, you actually get real high durability, right? There is no way you can actually, the durability percentage actually goes very high. It's up to like equivalent of S3 now with 11 nines. And the other advantage compared to RDS Postgres that you will get is you can go all the way till 64 terabytes for your database instance, like the single instance on how much it can use. So for reasons like for performance, what we do see is like the Aurora with Postgres compatibility gives you 3 times, up to 3 times, depending on the benchmarks you use, performance gains over standard Postgres. Also, the other neat technology it uses is, instead of multi-AZ, it uses read replica failover, along with the storage side. So if something happens, the same mechanism that I mentioned about multi-AZ, Aurora does it a bit differently with the read replica. It makes sure that all the writes are flushed to the read replica, and it promotes that. What we have observed in practical deployments, we are seeing time that it typically takes like 68 seconds on the multi-AZ. It drops to like under 30 seconds with Aurora. So it gives you faster recoverability if anything happens on your main instance. And also by optimizing the way it writes to read replicas, it actually now can have read replicas which are more like within single digit of replica lag. So it gives you replicas which are kind of more closer to your primary instance. So these are kind of like a lot of new benefits. If you're not tried Aurora, you can try it out. It is GA with the Postgres compatibility now. So we talk about like a lot of the features. Once you have deployed that, what you essentially want to do is monitor, right? Like what operations are happening and other things. So there are 3 ways we actually do monitoring right now on AWS. You get standard monitoring, which comes free as part of your deployments, which provides you with the most basic host level monitoring related to your machine. The way to kind of visualize it is the virtual machine level monitoring along with some key monitoring that we give you as part of RDS. So like some of the key ones that we expose at the database level is what are the number of connections to my database, right? So those are some of the things you provide. If you want more information about monitoring, there is an optional feature called enhanced monitoring. And what it does, it gives you host level metrics available to you for a more fine-grained monitoring that you want to do. So for one example that I can think of is like top, right? Everybody likes to see top output. So if you want to see kind of like a top output process view, you get that in the enhanced monitoring. And it also gives you more features like the breakdown of CPU, like into the system time and user time. It gives you the process list where you can find out like which process really uses my CPU time with the process ID that you can actually kill through the pSQL terminate backend command. So if you want to kind of like figure out like something is not right, I want to figure out like which query is kind of eating away my time, you can actually use the enhanced monitoring process list, find the process ID, use PG terminate backend through your pSQL and terminate it. With Aurora Postgres, we also now support a new way of doing monitoring, which is called Performance Insights. So Performance Insights is a time-based monitoring. It continuously makes 1-second samples on your instance and gives you information more from a database level point of view. The way it does that is it gives you a chart, which is a running chart of all your queries that are running. So you can actually figure out like which query, so it gives you different ways to kind of say, I can say list by queries, which will show you a graph with queries and who is consuming how much CPU. Or you can say, show me all the wait events that are happening, which gives you kind of like more system level, Postgres level wait events that are measurable in Postgres, like buffer IO or sync IO and all those information. So it gives you more fine-grained controlled for your database instances. Right now, this is available only in Aurora. It will be slowly coming to all RDS engines soon. From Postgres point of view, apart from this monitoring, you have more extensions that you can also deploy. So one of the popular module that we now support is AutoExplain. AutoExplain is a great module for doing something like this. I'm not going to monitor my instance all the time. When I encounter a slow query, I want to see the explain plan for it. Explain plan is a way of how you can see how the queries are executed on Postgres. With this module, you can now enable that in RDS Postgres and set a parameter like log mean duration for AutoExplain. So in this example that I'm showing, I'm saying 5,000 milliseconds. So any query that takes more than 5 seconds, an automatic explain plan will be dumped into your database log files that you can see. So if you parse your database logs, you will see all your slow queries come in. It basically also kind of doesn't spend time on any of the faster queries, so that kind of like bypasses for them, right? Another cool feature is like if you're using stored procedures, right? There is no an easy way to see the stored procedure explain plan, because if you do like a standard explain plan on a stored procedure, you'll get like a one-line execution running a stored procedure. If you want to see details for all the different stored SQL statements that are happening in stored procedure, AutoExplain gives you an additional parameter which is called nested statements on. If you turn nested statement on, and if you're running, and if that slow query is actually a function call or a stored procedure, it will throw more information, like it will throw the details of each explain plan for each of the statements that are running out there. This is actually a good way for debugging stored procedures also. So you can actually use that on RDS now. The other popular extension that we support is the standard pgstat statement. pgstat statement is great in a way that you enable it, you run all your queries. At the end of the day, maybe you just come back and say, hey, sort me by total time in a descending order to see who was my top query. And the way the top query total time is calculated, it calculates based on the count of the same query and the time it takes for each execution, right? So it gives you information like, for this query, the total time across all execution was this much, and it will give you details like what was my minimum time, maximum time, so you can see the variations on that. This is kind of useful if you're seeing high variations, which means like there are ways you need to look at to tune your queries. So this is actually a very useful extension for actually doing debugging. This is actually good information for people who are kind of monitoring and always want to get the top performance for all your queries out. Next thing I want to talk about is kind of like bloat management, right? Postgres uses MVCC, which means there are a lot of dead rows. Dead rows need to be cleaned up. Otherwise, it increases the database size. Typically, in Postgres, all your updates are essentially equivalent of a delete and a new entry out there. So that's how your new rows are coming up. So the utility to kind of clean up your dead row is called vacuum. There are two ways you can use vacuum. The standard vacuum cleans up your dead row, but keeps the space as it is, so the next row inserts will actually utilize them. If you want to release the space, you would use the full option, which would release the space back to the operating system. Postgres does these things automatically through a process called AUTOVACUUM. The standard, depending on your instance, the AUTOVACUUM may not be able to catch up. This typically happens if you have a database always under stress, which means there is load always happening out there. AUTOVACUUM doesn't get a chance to come up and clean up the old rows. So we do give you ways to kind of like, say, if you want to change parameters on that, you could do that. The standard ways that people actually bump up, tune AUTOVACUUM is by bumping up the max worker so it can go after multiple tables at the same time. Other way was to kind of like reduce when a table can be vacuumed. Like the standard default value for Postgres is about 20%, which means only if the bloat is like about 20%, that's when it starts to clean up. We normally recommend that like for bigger instances, you reduce that on to like 5%. We did make this change already. So if you're deploying the latest RDS versions now, like 9.6, we automatically set the default to now 5%. So AUTOVACUUM can become more aggressive out there. We now also support a utility called PGRepack as an extension. PGRepack is very useful. I talked about vacuum full to kind of clean up and free up the space. The problem with vacuum full is it takes a table lock, which means if you have a constant load on your database, vacuum full will bring the whole database to a freeze as far as your load is concerned. So if you have constant load happening on your database, you would use PGRepack. The way PGRepack works, it comes in, takes a chunk, resorts it, and then it takes a very small lock to kind of replace it back. And so it is pretty useful if you have like a production setup and you want to do bloat management and reduce the space out that. So PGRepack is actually now supported in the latest 9.6 version, latest minor releases of 9.6 on RDS Postgres. The other thing you still want to make sure that you are doing bloat management is not only just about size, but you also want to do that for something else. And that something else is like transaction ID wraparound. So to kind of go like a 1-minute quick view on that is transaction ID is a transaction counter, right? Which is a 32-bit, which means the scope of that is like 4 billion. At any given point of time, a transaction can come in and say, I have 2 billion old transactions view, and I have a 2 billion future transaction views. And because it is MVCC, it always needs to do and match to see what visibility I have, and vacuum essentially comes and cleans them up, right? Which means vacuum is taking your lower point up. If vacuum cannot catch up, it may happen that your transaction ID may actually roll over and you go above that, but because it's 32-bit, that same transaction will show up as a future transaction later on. So you don't want that to happen because that essentially means at that point of time, your database is no longer usable as such. It's gone. You have to kind of restore it back. So on RDS Postgres, what we do is we kind of keep a trend on that. We actually have a on your standard monitoring itself, we give you a way to track that transaction ID. And what we do is, like, if you cross like a 1 billion transaction, we also kind of like send out a warning to the customer saying, hey, you may want to kind of look and see if you want to run vacuum. If you cannot run vacuum, if you come closer to that 2 billion mark, we automatically it will issue the vacuum command on your behalf. Because if you don't do that, you will essentially go into a database that is in a read-only state only. That's something that we do it as a courtesy. So we do want people to kind of do their own monitoring and do vacuuming regularly out there. The other thing I want to talk about quickly is one of the common questions that I get is how do I make that my replica is not lagging far behind, right? So one of the standard suggestions that we give out to customers is make sure you are using some of the standard practices for kind of cutting down your traffic between your master to your replica. And then the other thing we want to make sure is like you set the right settings, which would help you to make sure your replica is always catching up. Typically, a replica will not catch up due to certain types of operations. Say, for example, you are doing vacuum on your primary. Your vacuum cannot be applied if there are read queries running on your read replicas. It will have to wait for the read replicas, your read queries to finish before it can do an apply. That causes lag to grow. Then there are certain data DDL changes. Say, for example, you're dropping a user, right? The user cannot be applied till all the queries that are still using that user have completed before it can wipe out. All this will result in increase in a replica lag. So the standard recommendation we do give out is to use hot standby feedback on your replicas to be enabled. What that does, it sends a feedback to your primary that, hey, I'm also doing this kind of queries right now, so don't even attempt to do the same queries on your primary. Because it is not really that the operation itself is a problem, but then there are other standard like updates that are happening after the operation will also be held back because it is always processed in order, right? So using the hot standby feedback will help you kind of reduce the lag between your replicas if you're seeing that as a behavior in your deployments. To kind of like make sure that you have a easy way to kind of see that, we do give you a metric as part of your standard monitoring metrics for your RDS instances. So you can keep an eye on that to kind of monitor how far or how behind your replicas are to your main instance. With that, I'm actually pretty coming close to all the things I want to talk about. If I don't answer your questions or if you get more questions later, you can use the AWS forums with the appropriate forum categories to kind of ask your questions. I believe we may have like 1 or 2 minutes for, I think we are running out of time, so I won't be able to take your questions. I'll be outside and I'll be able to take more of your questions outside. Thank you.